We're going to work on the one-to-one property for exponential functions. We have 5 raised to the x plus 2 as the exponent equals 5 to the 6th. The one-to-one property basically says if you have one equal base, you must also have one equal exponent. Since the bases are all already equal, the only way that this whole equation can be a true statement and be equal is if your exponents are equal. So since your bases are equal, that means your exponents, x plus 2, has to equal 6. So to solve this linear equation, subtract 2, you get x equals 4. So that's the solution for this exponential function. This is a one-to-one property, one base, one exponent. Your bases can be anything. I've picked numbers here. They can be variables, they can be anything else. But in order for this to be true, one base, one exponent. I have another one here. If your bases aren't equal, you can rewrite them as long as they are powers of each other. You can rewrite them to make them equal. We have 2 to the x minus 4 equals 8. We don't have the same base, so we've got to do a little bit of work first to make them equal. What you generally want to do is look at your lower base number, base 2, and 8 can be rewritten as a power of 2. Remember that 2 to the third power, 2 times 2 times 2 is 8. And so we're going to rewrite this where 2 to the x minus 4 then equals 2 to the third power. So now we have the same base on both sides, and since the bases are equal, the exponents must be equal also. So that means then that x minus 4 has to equal 3, and we're going to solve for x, so we're going to add 4 to both sides, and we get x equals 7. So that's the solution for this exponential equation. Remember, these are called exponential equations because you have a variable in the exponent. For my next example, I have one where I have 3 to the 2x equals 1 over 9. We've got two different numbers here. We don't have the same base. Other than the 1, look at your numbers, and 3 is a smaller number than the 9. And it's easier to write the 9 as a power of 3, so we're going to take care of that first. 9 we know is 3 squared, so we're going to change this to 3 squared. So then that's going to give us 3 to the 2x equals 1 over 3 squared. So I still have the same thing. I still have 3 to the 2x on the left-hand side, and I still have 1/9 on the right-hand side. It's just that I've rewritten my 9 as 3 squared. So we're almost there. We've got some same numbers on both sides, but they're not in the same location. I want both of these in the numerator or possibly both in the denominator. Remember that when you invert or take the reciprocal of a fraction, you change the exponent. So if I invert this and make it 3 squared over 1, then it becomes 3 to the negative 2. And you can put the 1 underneath it if you'd like to, but remember that can be left off. So now I have 3 to the 2x equals 3 to the negative 2. I've rewritten my problem now so that I have the same base on both sides. So if my bases are equal, then my exponents must be equal. Since they're already equal, I ignore those, and I'm going to say 2x then has to equal negative 2. This exponent on the left has to equal the exponent on the right. Solve for it, we divide by 2, and we get x equals negative 1. So that's our solution. And remember, anytime you want to check, you can always go back and put it in the original. So let's check this one. If I put negative 1 back in place of x up here, 3 to the 2 times negative 1 is 3 to the negative 2. Remember, that means 1 over 3 squared. I took the reciprocal, exponent changed from negative to positive, and 3 squared is 9, so yes, it equals 1/9. So those are some examples of exponential equations and the one-to-one property.